Okay, real quick, want to talk to you guys about growth and decay. So I'm just going to write out some functions here. So here's a function, f of x equals 100 times 2 to the x power. And I'll write another one. Okay, there we go. So what I want you to notice here is they both have the 100 sitting in front, so that's not what I'm talking about. I'm not talking about the number in front. It makes no difference. What I am talking about is the number inside, in this case, the parentheses. Those two things are called growth rates. So that is a growth rate. Actually, I'm going to say it's either growth or decay. And that number right there is going to be what we call the growth rate. But technically it could be a decay rate. So the question is, which one is it? Well, it turns out that if that number is greater than 1, so I'm going to actually call it b. If b is greater than 1, then you get a growth function. But if that number, again call it b, is between 0 and 1, you get decay, which causes the graph to go down instead of up. So not very hard to see here, since this number, that's the b number, that's a, and this is b, that number is bigger than 1, so it's totally growth instead of decay. Whereas over here, that number is smaller than 1, 0.75 or 3/4 or whatever the number might be, it's smaller than 1, therefore it is decay. Just in case, just to increase your understanding here, the idea here is that a growth function, if I was to make a quick sketch of it, is basically going to go like that and go up, whereas this kind, the decay ones, sort of fall down like that. Okay, so let's look at a word problem that might involve growth. So, real sort of silly here, a group of 50 bacteria double every hour. So how many bacteria would you have in 6 hours? And then another question, when would you have 10,000 bacteria? So the equation for these kind of things are very simple. Remember, it's basically of the form y equals a times b to the x power. And the a number is your starting value. Furthermore, your b number is your growth or decay rate. In this case, growth. So to write our equation, it would be y equals, they tell us we start with 50, they tell us the growth rate, which is doubling, which means the number 2, and then it'd be to the x power, and x represents the number of hours, I suppose. So A says, how many bacteria would you have in 6 hours? Well, that's easy to figure out. 50 times 2 to the 6th power. And you'd grab a calculator probably, unless you can do that really fast in your head. I get 3,200 bacteria. All right. Letter B, when would you have 10,000? Nothing special about that number, but just when would you have it? Well, the idea there is that we would be solving for that. 50 times 2 to the x power, like what power, would give you 10,000. So to solve for that, you can use logarithms, which is what we've been practicing in class. I mean, it is an exponential equation, and we've learned to use logarithms to solve that. So I would begin that solving process by doing something like dividing by 50. I really wanted to get that 2 to the x power all by itself. And after doing that, I would get 2 to the x power equals whatever 10,000 divided by 50 is. I believe that that would be 2,000. Okay, so I feel like double checking that. I'm second guessing myself. That's actually 200. Better. Sorry about that. Broke my train of thought. 10,000 divided by 50, definitely. Okay. So now we can rewrite that with logarithms. So we've learned to sort of do this little spiraling thing with logarithms, and we could say, hey calculator, the logarithm base 2 of 200, what would that give you? So you would just grab your calculator using that fancy button that we've learned, and you would type those in, and I get 7.64, which is basically 7.64 hours is when this equation would think that I've got 10,000 bacteria. So that's hours right there. All right, that's it. All right, so let's look at a decay problem. We have a $16,000 truck, and it's said to depreciate at a rate of 14% per year. First of all, remember that depreciate means it just goes down in value. So again, sort of following the basic understanding that we are dealing with an exponential equation, a times b to the x power. What would our equation look like for this one? Well, this one will be a little bit more complicated because of the percent. The last one was just doubling. That was easier. Y equals our starting number, which would be 16,000. And then the growth rate here is actually going to be a little bit more complicated. It's still going to be something to the x power, though. Now, because it's a percent, in math class, 14%, we would normally convert that into a decimal by dividing it by 100, so 0.14, or I'm sorry, 14 divided by 100 is 0.14. So it's tempting to just put the 0.14 in there as a decay rate, but that's actually not completely true. While it's true that we're losing 14%, the math equation actually needs to know what you're keeping, and so the idea here is that you're subtracting some money each year. In fact, you're subtracting 14%, so it's actually 1 minus 0.14. That's just something we saw in class. Now, we can sort of clean that up a little bit. So y equals 16,000, and the idea there is that 1 minus 0.14, or in other words 100% minus 14%, is actually 0.86, and that would be to the x power. It's just a little bit cleaner and easier to use, but technically either one of those is fine. So letter A, what is the truck's value after 3 years? So you would go, well, 16,000 is what I started with, and it's going, it's losing some value. It's losing 14%, or you could say it's keeping 86% for 3 years. What is that value? And you'd grab a calculator and just have at it. So 16,000 times 0.86 to the third power. I'm getting a value of $10,176 and some cents. The decimal is 896, so that's actually like 90 cents. So there you go. Letter B, when will it be worth 6,000? Well, that's more like solving. So we could just play around with the exponents, but we're going to ask you guys to do logarithms on that. So to the x power, and I want to set that equal to 6,000. So we need to solve that equation. So we do need to use logarithms, but first I need to isolate this part here. I got to get this thing by itself. So I would start by actually dividing by 16,000. Now the idea there is that that gives me just 0.86 to the x power equals, and then 6,000 divided by 16,000 is a decimal, 0.375. Now, I use logarithms. I spiral. Rewrite it as a logarithm. That's the beauty of logarithms. They solve exponential equations. So log base 0.86. Now your calculator is going to take care of that, so that's not stressful. And then inside the parentheses would be 0.375. So I just need to grab the calculator, use that fancy button that we've learned, and go see what it has to say. So alpha window 5 brings up the little log base, and I do 0.86 and 0.375 Wish I could show you that, but that gives me 6.5, basically. So when will it be worth 6,000? After approximately 6.5 years. Hope that helps. Be ready for those.